Chemistry and you are watching Chem Science.
In this video, we'll be solving the remaining questions of the question paper 2-2 of 9701 Chemistry Examination Series October-November 2022. As we have already solved question 1 and 2 in our earlier video, so let's continue with the next questions. So starting with question 3 here, organic compounds can be distinguished using chemical test and analytical techniques. Table 3.1 shows 4 pairs of organic compounds, and what we are supposed to do here is, let's see the below part of this question where it says complete table 3.1 to identify a reagent which can distinguish between the compounds in each pair, give the positive result of the chemical test and identify which compound shows these result. So let's go ahead with the compounds and the test. And so our first compound here is A1 and A2. Now in A1 and A2 we can see this is an aldehyde. CHO is an aldehyde and A2 is only CO, that is ketone. So if we want to distinguish between aldehyde and ketone, we can use a Tollens reagent or Fellings reagent. If I am using Tollens reagent here, then what will be the positive test? A1 will give the silver mirror test. A1 gives silver mirror test. Silver mirror. Okay, let's go ahead with the B1 and B2. B1 we can see there is a ketone group, and in B2 also there is a ketone group. So what's the difference here? Ketone group is besides the CH3 group, and in B2 the ketone group is in between the whole compound. That is, there is a CH3 CH2 group on both the sides of the ketone functional group. Now there is only one test which can distinguish methyl ketone. We call B1 as methyl ketone because that is CH3CO. So alkaline iodine. Alkaline iodine can be written, or you can write iodine plus NaOH. That is also acceptable. Alkaline iodine or iodine plus NaOH. Now in B1 will give yellow precipitates. Will give yellow precipitates. That is the positive test because it's going to produce the triiodomethane, which is a yellow in color. If we go ahead with the next compounds pair, then C1 is again a ketone group, but C2 is having an ester group. COO is the group. So if we want to distinguish, we can use 2,4-DNPH, that is 2,4-dinitrophenylhydrazine, that is 2,4-DNPH. And 2,4-DNPH is a test to identify any carbonyl group, whether aldehyde or ketone. So here C1 is ketone, and C1 will give red precipitates, or even you can write orange precipitates. So C1 will give red precipitates as a positive test. Next pair of compounds is D1 and D2, where D1 is having an alcohol group, D2 is also having an alcohol group. So what's the difference? D1 is an cycloalkane because there is no double bond, but D2 is having a double bond, so it's an alkene. Now for alkene, the only famous test is aqueous bromine, or you can write bromine water. We can write bromine water, and the positive test will be given by D2 because D2 will make a color change. So D2 will change orange color to colorless. Orange color to colorless. That is the test given by D2 because of the presence of an alkene group. Now let's see the next part of the question. Next part of the question here says A1 and A2 are the structural isomers. Define structural isomers. Now let's have a look at A1 and A2. Yes, A1 and A2 are structural isomers because they have the same molecular formula. So what are the structural isomers? So structural isomers are the molecules, they are the molecules with same molecular formula, but different structural formula, because they are the structural isomers. So structural formula or the structure will be different, but the molecular formula remains same. Next question says give systematic name of B2. Now let's see what is B2. Going back to the table, we need to have a look at B2. Okay, B2 is having a ketone group, and let's count the number of carbon atom: 1, 2, 3, 4 and 5. So 5 carbon atoms are there with a ketone group on the third carbon. So if we name it systematically, so pentane will definitely come, but it is a ketone on the third position, so we can write it as pentane 3-on. Pentane 3-on is the systematic name because it has 5 carbon atom with the ketone group on the third carbon. Next question says deduce the molecular formula of D1. Let's again see what is the molecular formula of D1. D1 is having 1, 2, 3, 4 and 5 carbon with hydrogen on each. So here are 2 hydrogen, 2 more hydrogen, so 4, 5, 6, 6 plus 3 hydrogen, so 9, and 1 more hydrogen, so 10 hydrogen and 1 oxygen. So the molecular formula of D1 is C5H10O because there were 5 carbon atom, 10 hydrogen and 1 oxygen as we had counted. Now D2 forms polymer Z when heated gently. Identify the type of polymers that forms from D2. Now as we know already that D2 had 1 alcohol group and 1 alkene group with C double bond C. Now only single alcohol cannot form a polymer, so the functional group which forms a polymer is the double bond, that is alkene group. So the type of polymerization will be addition polymerization because alkenes forms the addition polymerization. So addition polymers are the type of polymers formed from D2. Draw one repeat unit of polymer Z. Now for that let's have a look at structure of D2. Again D2 we can see that there is 1, 2, 3, 4 carbon atom, and on the fourth carbon we have alcohol, and between the first and second carbon we have a double bond. So the addition polymer will be formed between the first and second carbon atom. So I'm drawing the first and second carbon atom here, but then there were 2 more carbon atoms with an alcohol group. So I'll write CH2, CH3OH. Why am I writing it on the top? Because the 2 carbon carrying the double bond will form the polymer, and that double bond will change into single bond. So this is the polymer that will be formed. So understand here we had the structure as I'm drawing here, that is the structure of D2 I'm drawing here. Okay, this is the structure of D2 with the double bond between the first and the second carbon atom. So these two are the carbons which is going to polymerize and get extended bonds on both the sides, and that will form the repeating unit. So repeating unit in any addition polymer will be the only 2 carbon atoms carrying the double bond. Okay, so here we have drawn only 2 carbon atoms carrying the double bond as a repeating unit in between, and the remaining part of the chain will be bonded to the second carbon atom. So I'm drawing it on the top because that will be as a chain in the polymer. So this is how we are going to draw the repeat unit of any addition polymer. Remember, addition polymer will have only 2 carbon in the repeat unit carrying the double bond. Okay, let's go ahead with the next sub question. where we can see that some organic compound E is given. Organic compound E contains 3 carbon atoms. E reacts with cold dilute acidified KMnO4 to form a single compound F with the molecular mass 154.9. Now figure 3.1 shows the infrared spectrum of E. Figure 3.2 shows infrared spectrum of F. Now here we have two structures, E and F. Let's see what is E structure here and then F structure here. Okay, so what is the main difference between the two structures? We can see that there is a main structure at about the peak of 3000 here is one peak, and the organic compound F. Organic compound F have another peak at about 3000, which is a broad and a wider peak. At 3000 again it is more sharper than the peak in the compound E. So the main difference is here at the peak about 3000. Now let's read the question below it. Here is a table of the infrared spectrum showing the characteristics absorption in this given range. Now both spectra shows absorption between 2850 and 2950 centimeter per centimeter owing to CH bonds in each molecule. Use the two infrared spectra and table 3.2 to identify the functional group present only in E. Explain your answer referring only to the absorptions at a frequency greater than 1500 per centimeter. Now we are talking about the infrared spectrum only of the peaks above 1500. And so first have a look at the question, understand what's the difference, then we'll have a look at the table given here and we'll understand what is the difference. Understand the question again. Use the two infrared spectra, table 3.2, and identify the functional group present only in E. That is the main question. So let's see the structure of E structure. Question of E, let's see what is there. Organic compound E contains 3 carbon atom, okay, and E reacts with cold dilute KMnO4 to form a single compound F. So if E is reacting with cold dilute acidified KMnO4, I guess there should be a C double bond C which reacts with the cold dilute acidified KMnO4 to form an diol. That is the main reaction which we have studied here, and that compound should be F. So according to me, in E we should have an infrared spectrum in the absorption range of C double bond C. Now let's have a look at the table also for that. So looking at the table here, the C double bond C range should be in 1500 to 1680 range. Now is that present in the spectrum of E? Let's see that 1500 to 1680. Yes, we have one peak here which is in this range, okay. So that shows that E should be having an alkene group, and as I have guessed that E changes to diol, so the F should be having an alcohol group, that is the OH group. Now if we have a look at the spectrum again and the table, OH group should have an hydroxyl group. Hydroxyl means alcohol, should have a peak in the range of 3200 to 3650. Now let's see how the F spectrum got that range. Of course, yes, we have this peak which we have pointed, that is in the range of the same, because here we can guess it should be approximately 3400 in the same range lying. So obviously then F is an alcohol group. Now let's see what is the question again, as we have understood the whole spectrum. Says explain your answer referring to only absorptions at the frequencies greater than 1500 per centimeter. So as we have identified, in E we have one C double bond C functional group, or you can say there is an alkene functional group, and the explanation what you will write here is that E is E has absorption, or you can say E has a peak in the absorption range of 1500 to what was the range? It was 1680 per centimeter. That was the range of alkene functional group. Okay, next sub question here says use the infrared spectrum of F to identify the functional group formed when E reacts with the cold dilute acidified. KMN4, explain your answer referring only to the absorptions in the frequencies greater than 1500. Now, as we have already studied that F has a functional group of alcohol, so you can write OH or you can write hydroxyl group. Hydroxyl functional group, that's the name which we give to alcohols. Now the explanation is that it has a broad peak. It has a broad peak, or you can say a broad absorption in the range you can see in the table above that the range is 3200 to 3650 per centimeter. So that is the range we are expecting for an hydroxyl group. Okay, let's see with the next question here. It says the mass spectrum of E shows a molecular ion peak and an M+2 peak of approximately equal abundance at M/E ratio of 120 and 122. Deduce the relative molecular mass MR of E. Now understand the question again. It says that the mass spectrum of E has two peaks at 120 and 122 and both of equal abundance. So you can say that both the abundance is 50-50% each. So we have to directly take the ratio of 120 plus 122 divided by 2 and we get the answer as 121. Because the abundance is equal, so we can directly take the you can say average. But if the abundance is not equal, just like chlorine, then we'll have to use a different method of finding the relative atomic mass. The next sub question says use the information in 3C to suggest a structure of for E. Now I remember, but if you don't remember, you can always pause, rewind, go back and read the question again. But I remember there were 3 carbon atoms in the organic compound E, plus it has an alkene group, that is for sure. Plus it has shown M and M+2 peak of the equal abundance. That shows it has an halogen, and which is bromine, because bromine is the only halogen which exists as 2 isotopes with equal abundance. So M and M+2 peak, if has the same abundance or same peak height, then it should be a bromine. So if we talk about, there are 3 carbon atoms. So let's draw the 3 carbon atoms with 1 alkene at any end and then bromine bonded to any other carbon atom. So remaining hydrogen we can bond, so CH, CH2, and so this is the structure I suggest for E. The simplest structure which is possible with an alkene and an halogen bromine. Let's go ahead with the next sub question, which says complete the equation for the reaction of E with cold dilute acidified KMnO4 to form F. In the equation, present O represents cold dilute acidified KMnO4. So here we need to write the molecular formula of E again, which is C3H5Br. Molecular formula of E is C3H5Br. As we know, there were 3 carbon atom, alkene group and bromine, so ends up with 5 hydrogen and 1 bromine, and so it ends up with diol. Now if I draw a diol somewhere here with the 2 carbon atom carrying the double bond, so here I'll have CH2 with OH group here, 1 H here and an OH group here and CH2. So now if we have a look at this, then again we have 3 carbon atom. Number of hydrogen you can count is H7, and we have Br also, and then we have 2 oxygen atoms. So here the molecular formula should be C3H7Br BrO2. And to be on the safer side, have a look at the equation. Is it balanced? Yes, C3 is as such. Hydrogen were 5 on the reactant side, but then 2 more hydrogen from the water ends up with hydrogen 7, 1 bromine as such on both the sides, and then there are 2 oxygen, 1 oxygen from the water and 1 of the oxygen from the oxidizing agent KMnO4. So 2 oxygen. Yes, the equation is balanced. And so let's go ahead with the next sub question, where it is a D sub question, which says C2 can be synthesized using A1 as a single organic reactant. So A1 is given here, C2 is given here. Devise a multi-step synthetic route to form C2 from A1. Identify relevant reagents and conditions and state the organic products of each step. Now understand, what are we supposed to do? We have A1, which is an aldehyde. We have C2, which is an ester. Now if you have a close look at A1, we have only 3 carbon atoms, but in C2 we have 1, 2, 3, 4 and 5. So 2 more carbon atoms are added. Okay. So devise a multi-step synthetic route. So it's not only the one reaction which will change A1 to C2. We are supposed to use a multi-step synthetic route where we can add more reagents. We have to identify the relevant reagents and conditions and state to form the organic products which will further change into C2. Okay, I forgot one more point, that in C2 we have total 6 carbon atoms, because 1, 2, 3, 1, 2, 3. So there are 3 carbon atoms on both sides of the ester group. Okay, we have, it's also written that synthetic route using A1 as a single organic reactant. So we are not supposed to use any other reactant. A1 is the only reactant which we have to convert. So that shows that we have to use A1 twice. Why? Because A1 has only 3 carbon atoms, but C2 has 6 carbon atoms. So that shows A1 should be changed in 2 different compounds in 2 different ways and then combine them to form C2. Now one more point. C2 is an ester. Now ester is formed from an alcohol, that is OH group, and an carboxylic acid. That shows that A1 should be first changed to alcohol, and then in the next step A1 should be changed to an carboxylic group, and then both the products reacts to form C2. This is how we can think and design our synthetic route. Okay, if A1 is an aldehyde, how to change it into an alcohol? Simple, easy step. So I'll write reaction 1. Reaction 1 should be A1 should be reacted with an reducing agent. It can be AlLiH4, that is the most famous reducing agent, or you can write NaBH4. That's going to change it into propanol. Why? Because that's a propanol aldehyde A1. So AlLiAlH4 or AlLiH4, that is lithium aluminium tetrahydrido. We can write LiAlH4 also. That is a better. So let me change it. LiAlH4. That's the reducing agent that will change A1 into propanol. Now the reaction to again change the A1 into an carboxylic acid. Now if it's an aldehyde, how do we change it to carboxylic acid? That is Propanoic acid we need. Propanoic acid we need. So we need to use an oxidizing agent, and the simplest oxidizing agent that changes aldehyde to carboxylic acid is potassium dichromate, K2Cr2O7 in an acidified condition. So as if to mention acidification, we are writing H plus, that mentions the acidified potassium dichromate. Now in both the reaction we can write heating also. Heat I am adding in both the reactions. So A1 is first changed to propanol, that is alcohol, and the next step A1 is changed to the propanoic acid, and now both the products are going to react and form C2. So in reaction 3, let me specify the molecular formula. So molecular formula of propanol is CH3, CH2, CH2OH, and propanoic acid is CH3, CH2, COOH, that is the propanoic acid. And to make ester from both of these, we need to have a concentrated sulfuric acid, that is H2SO4, and a heating is required, and the product formed will be C2. C2 we can write, or we can write the molecular formula from C2, that is CH3, CH3, CH2, COO, CH2, CH2, CH3. This is the C2 compound which will be formed after esterifications of the reaction 1 and reaction 2 products. This is how C2 is formed. And in this question we have noted that the organic questions, though was only one organic question, but it was a longer question and quite easy. I hope this paper is solved nicely. So here is the whole question paper solved. Question 1 and question 2 solved in the earlier video, and question 3 organic solved in this video.